discussion on climate change and you. Today we have with us a learned faculty on the topic, Dr. Mrityunjay Mohapatra, DG of Meteorology. I would request DG ma'am to please welcome today's faculty by presenting a planter. And has played a vital role in enhancing early warning services in IMD, particularly for cyclones and impact-based forecasting. Sir is widely known as the Cyclone Man of India and has earned recognition from national and international agencies. Sir has authored more than 165 research papers and has at its credit many awards and honors. Few of them to mention is American Meteorological Society Award for Leadership in Tropical Cyclone System and UN Sasakawa Award 2025 for Disaster Risk Reduction. Sir, it's a great opportunity to hear from you, and all of us are all ears and looking forward for an enriching and engaging session. Thank you.
Slides are moved from there. Whenever you say next, my man will.
Okay. Otherwise, if keyboard can be kept here, I can operate also.
Actually, it is being
Okay.
live streamed, so
Fine.
you have to say just next, and they will move the slide.
Fine, no problem. Namaskar, good evening to all of you. Respected Director General, NCA-F Madhavidas Madam, DDG, Kapoor Sahab, Director Pooja Madam, distinguished delegates, participants, ladies and gentlemen. At the outset, I express my deep gratitude for inviting me to interact with you and deliver a talk on the present day topic. Everyone, be it a student or be it a farmer or be it a businessman or be it an administrator, policymaker, all are worried about the particular term, the climate change. And when we all are worried about that, so also we should understand the roles and responsibilities of ourselves as an organization, as an administrator, as a policymaker, as an individual. What is our role and responsibilities towards this climate change? My presentation today will just explain about the science of climate change, various aspects of climate change, policy and plans, and the role of the individual. Next, please.
Slide लगाइए.
Kitna time, how much time we can take?
So around 70 minutes.
Fine. So I will have, as I was discussing, that the science of the climate change and some impacts of the climate change and various adaptive measures and mitigative measures adopted by the society and the country. Then role and responsibility of the individuals, that I will focus on. Next, please. Please, one more. So knowingly or unknowingly, sometimes you will find that you are a forecaster. It is not like that I am a forecaster. Whenever you get up from the bed every day, you come out, look at the sky. And you yourself become a forecaster, assuming that if it is clear sky today, it will be clear. If it is cloudy, it may rain today, and like that. And also have been taught with that in our childhood. The morning shows the day. So that is a tool or technology provided in childhood to us by the society or by the teachers, by the parents, that you can predict if you look at the morning sky. But that is not true always. When you look at the clear sky in the morning, it does not guarantee you that it will be clear. For example, today's morning, it was clear when you got up from the bed, but it started drizzling, then raining throughout, and now it is clear, becoming clear. So this is called as the variation in weather, which is very rapid, which can change instantaneously from 1 minute to other minute. But at the same time, when you are planning, for example, to visit Kedarnath, or to visit, say, Badrinath, or visit Puri, or Calcutta, or say Dwarkanath, so immediately you remember what could be the weather at that time. You might be planning, for example, 1 month ahead, or you might be planning, for example, 1 year ahead sometimes to go for Europe. So at that time, it may not be possible to provide you with the information on weather. What will the weather on, say, for example, next year, 22nd July 2026. But you are planning to go on this particular days, for example, to Washington DC or to want to go to London, I can tell you some average information about the weather. What will be the weather next year or next to next year or after 5 years? And that average weather conditions which we provide to you is called as the climate. So this is the difference between weather and climate. While weather is instantaneously varying, the climate shows a slow process. The climate remains almost same because of the rotation of the earth around the sun. There is a seasonal behavior of the climate, and we get climate almost very periodically. Say, for example, monsoon comes in the month of June and continues till September. Winter comes in December, continues till February. Summer starts in March and it continues till beginning of June. So like that, there are certain features which is very periodic, and by that way we define the climate. So if I know the climate of a particular place, I should have long-term observations of weather. And the average condition of those long-term observations of weather defines the climate of the place. But at the same time, if you ask a old person who is 100 years old, so how is the climate in your childhood, now is the climate in your this old age, you will say that it is paradigm shift. Climate was not like that, climate was like this, now it is like this, not like that. Yeah, you may say that yes, memory is too short, we cannot remember so many things. But certainly if we remember ourselves in our childhood and now, there is a lot of changes. The changes in our environment and accordingly changes in the weather and climate patterns. So this is called as a shift in climatic behavior. When there is a permanent shift in climatic behavior, it is called as the climate change. If there is no permanent shift, so there is a variation, then it is not called as the climate change. It is rather called as the interannual variations or intra-seasonal variations or the diurnal variations or day-to-day variations. So there is a little difference between climate variability and the climate change. Climate variability means it is a variation from year to year. Say there could be the floods, could be droughts. There could be excess rainfall in certain year, there could be deficient rainfall in certain year. That is not called as the climate change. See, if it is rained heavily today, you cannot say that it is a climate change. I will say it climate change if I see that in the past 30 years, average climate of the weather over Delhi, say for example, temperature is becoming 42 degrees Celsius in the month of May, average temperature past 30 years, and earlier it was 40 degrees Celsius. Then I will say that yes, there is a climate change, 40 has become 42. So with this background of the definition of weather, climate and climate change and climate variations, I want to say that all these what you realize, whether today's rainfall or temperature or the cloudiness or the humidity, these are all the byproducts of various interactions. There are interactions between the various spheres of the earth. The most important sphere is the atmosphere surrounding the solid earth. In the solid earth, we have got the lithosphere, the crust. And also we have got the biosphere, the life. It is not simply human life, animal lives, plant lives. So entire biosphere. Also we have got the hydrosphere, like oceans, rivers, water bodies. And also you have got the cryosphere, the ice, glaciers, say Antarctic ice, Himalayan snow cover, Eurasian snow cover. So there are many such solid water forms. These are all called as the cryosphere. So all these spheres, I just mentioned in the diagram here, are not independent of each other. They are interacting with each other. Atmosphere is interacting with, say, ocean. You may say, how? If you remember your childhood, you might have studied the water cycle. Because of this incidence of the sun's rays on the water body, the water gets evaporated. And that evaporated water goes off in the gaseous form. And the weight of, say, water particles, that is water molecule, is 18 grams. But dry water, or dry air, you can say it is 28 grams. So therefore, the water vapor goes off and off. And again, if you remember your childhood, those who were studying in the English schools, they might have read that higher you go, cooler you feel. That rhymes. In the atmosphere, if you go up to troposphere, say height of about 8 to 15 kilometers, the temperature falls gradually. Okay, so when you have a temperature of say 30, 40 degrees Celsius here, their temperature will be around minus 50 degrees Celsius at a height of about 10 to 15 kilometers. So when this warm water vapor is going up, it is coming in contact with the cold air and condenses. These condensed particles collapse with each other and they form the clouds. This is called as cloud. Cloud is nothing but a collection of the water particles. And when they collapse with each other, their size increases and time comes when they fall down. When they fall down, it is called as the rainfall. And this rainfall may be in three forms. One is the rainfall. You know, sometimes there will be hailstorms, olavrushti, and sometimes you will find that there will be snowfall. So therefore, we also, when we offer water to the sun, we say that akashat patitatrayam yatha gacchati sagaram sarvadeva namaskaram kesung pratigacchati. So there are three forms of water which is falling from the sky. It is written in our traditional literature. And this water cycle, what I explained you can find this mention in our Vedas, Aditya Jayate Vrishti. The sun generates rain. And that Aditya Jayate Vrishti has been taken as the emblem of it's the same radiations. So whatever radiation Earth is receiving, it is also emitting. But while emitting, it is not emitting the same frequency of wavelength, it is emitting the equivalent frequency, that is a long wave frequency. So long wave radiation emitted by the surface of the earth cannot escape the atmosphere, while the short wave radiation emitted from the sun escapes the atmosphere, reaches the surface of the earth. And this long wave radiation gets trapped by certain particles available in the atmosphere, and those particles are carbon dioxide, water vapor, methane, nitrous oxide, fluorocarbons, etc. But in the natural environment, when we talk of natural environment, there are no such particles except the water vapor and the carbon dioxide. And there is a cycle, water cycle, carbon dioxide cycle also. But now what happened actually after 1850 with the industrial revolution, commencement of industrial age, the man-made factors came out of existence. There are many man-made factors which have contributed towards the imbalance in the atmospheric constituents. These gases, which can trap energy emitted by the surface of the earth, are called as the greenhouse gases. So greenhouse gases, do you want greenhouse gases or not in the atmosphere? Can somebody guess? Do you want greenhouse gas in atmosphere or not? No. Anyone? Yes? Yes. Yes. If there is no greenhouse gas, you cannot survive, we cannot survive. Had there been no greenhouse gas in atmosphere, that means there is no carbon dioxide, there is no water vapor, then what will happen? Our temperature could have been perhaps minus, average temperature of the surface of the earth at present is 15 degrees Celsius. It could have been minus 30 degrees Celsius or minus 35 degrees Celsius, something like that, where no human being can survive. So therefore, greenhouse gas is an essential evil. You need it. But we should maintain it, we should balance it. We should not eject more greenhouse gases in the atmosphere. However, now we will first talk about the natural causes. Natural causes are the greenhouse gases. These are the natural gases like carbon dioxide and water vapor. Then we have got the celestial variations. They have got solar output, we have got the volcanic eruptions, we have got plate tectonics, and there are other mechanisms which influences the weather and climate over the surface of the earth. Next slide, please. You know, understand all these, how they are influencing. For example, volcanic aerosols. In a volcanic eruption, a lot of aerosols comes off. And these aerosols, if you remember the past volcanic eruptions, you will find that it becomes completely obscured. There will be sunshine, no sunshine, and you will get temperature going down. Okay. Now, naturally, what happens actually, we know that Kepler's law, that Earth is rotating around the sun in an elliptical orbit. We studied it. But is it true that? So Milankovic theory says that it is not always elliptical. It can be elliptical, then becomes, you can see the diagram, it can become elliptical, then become circular, then elliptical, then circular. There is a periodic variation in the orbit of the Earth around the sun. And this is of the order of 90 to 100,000 years cycle. Similarly, when Earth is rotating, it is making an axis, the inclination is around, say, 21.5 to 23.5. It varies, it is not fixed, it changes. And this change also takes place in different periodic variations. Similarly, in the childhood you might have studied, you might have played that टॉफ नो क्या बोलते हैं इसको, धागा घुमा के इसको छोड़ देते हैं, वो घूमता रहता है. आपने ऑब्जर्व किया है कि यू हैव गुड ऑब्जर्वर इफ यू नो अबाउट द नेचर. सो धीरे धीरे ये तो स्ट्रेट घूमता रहता है ऐसे, धीरे धीरे यू विल फाइंड दैट इट इज बिकमिंग स्लोअर एंड इट इज रोटेटिंग लाइक दिस. ओके, दिस इज कॉल्ड एज द प्रिसिशनल मोशन. Okay, not to precisional motion. So this precisional motion is also exhibited by Earth. It is rotating around its own axis. It is inclined in certain direction, say 21 to 23.5. It also shows the precisional motion. And this precisional motion has the periodicity of 20,000 years. So you've got a cycle of 20,000 years, 40 to 60,000 years, and 90 to 100,000 years, 3 major cycles. Accordingly, we see the glacial phase, interglacial phase, when a temperature going down and temperature going off. Now, it has happened recently, Middle Ice Age, if you remember, around 1850, when entire Europe was covered with the ice. Okay, next please. So these are the natural causes for solar outputs. The sun is the ultimate source of energy. And we know that amount of energy which is coming up from the sun towards the surface of the earth, 2 Langley per minute. But that is not fixed. Sometimes there could be, say, sunspots. And there is a cycle, 11-year sunspot cycle. Number of sunspots increases, then sunspot decreases, etc. There could be solar flares. There could be various astronomical bodies interacting. So therefore, solar output, though it is continued as a fixed, but it is not fixed. There could be variations. Next, please. There could be volcanism that I told you. Because of volcanism, there are various aerosols, mainly the sulfur dioxide, which comes up to the surface of the earth into the atmosphere. Next, please. So this is the greenhouse effect I wanted to explain you. You continue that. Greenhouse gas, I was telling you about, there are different types of gases. I have explained this point actually. See, for example, the incoming radiations, it is getting reflected, but most of the radiation gets reflected, gets reflected from the surface of the earth. When it gets reflected, it gets absorbed by the gases as it present in the atmosphere, like carbon dioxide and water vapor. Now there are other gases like methane, etc., nitrous oxide, etc., they are also absorbing. Therefore, the additional increase in temperature is coming up because of the extra release of gases by the human activities. Next, please. Now, if you consider the natural process, we have got the earth, water, and carbon dioxide. So because of that, our average temperature is 15 degrees Celsius. If there would have been no carbon dioxide and water vapor in the atmosphere, the temperature could have been minus 18 degrees Celsius. So therefore, we could not have survived. So there is a rise of plus 33 degrees Celsius because of the presence of the carbon dioxide and water vapor. So therefore, now if you go on changing, then certainly the temperature can also change. Similarly, the situation given here for Venus and Mars. Next, please. Why you are not able to stay in Venus and Mars? Because of these phenomena. Now, so what I want to say that till now we have discussed about natural phenomena, but in addition to that, there is another sphere which we have added into the natural environment. That is called as anthrosphere, or the sphere arising out of the human activities. This anthrosphere is not limited only to atmosphere, but also anthrosphere is there with the soil. Anthrosphere is there with respect to the ocean, everywhere. We are playing with nature everywhere. Our soil is also polluted, our atmosphere is polluted, ocean is also polluted. Antarctica is at present is not polluted because there are so many rules and regulations, but we do not know by the way we are moving towards Antarctica, and now also we are moving towards space. So we have to be very much careful about preserving the sanctity of the various spheres of the earth. Next, please. Next, next. Okay, this is the anthropogenic gas. Next, just break down. So if you look at this anthropogenic gas, I discussed what are the sources of these anthropogenic gases. The most important source is the industry, industrial processes, which releases maximum amount of greenhouse gases, and there could be coal mining. So therefore, nowadays throughout the globe there is demand that we should have the sustainable industry, we should have no coal mining. Coal-based industry should stop. And also there are other sources like, say, air pollution because of the transport, urbanization, so many activities. And there are also sometimes deforestation. We cut the trees, we do not replace the trees, etc. So that also contributes towards the increase in greenhouse gases. Next, please. Then you have got percentage distribution. You can see how much is the percentage distribution. This is the carbon dioxide which is contributing towards the 64%. So major is the carbon dioxide, and of course we have got the methane, chlorofluorocarbon, nitrous oxide, etc. Next, please. Now, if you look at the entire globe, you will find that there is an increasing trend in carbon dioxide. So at first when the study was taken up, then they decided that we should have an observatory which is completely independent of any industrial activity so that you can measure about the changes. So that was the Mauna Loa. And the carbon dioxide concentration, you can see how much it is increasing, continuous increase, just like along the diagonal of the rectangle, it is going on increasing. Of course, there are cycles, it is embedded with the cycles. And recent trend in CO2 also you can see with the embedded cycles, it is also going on increasing. This is just an example of how it has increased. At present, it is about, say, 421 parts per million volume. And in March 22, it was 418.8 parts per million volume. In 1 year, how much we are increasing. So this is the contribution what we are making unknowingly or unknowingly as an Abhimanyu, I told very well, as Abhimanyu we contribute towards the degradation of the atmosphere. Next please. Okay, so globally therefore if you just look at that, people argue with this, that what is the contribution of India, what is the contribution of US, what is the contribution of Japan, what is the contribution of UK or other countries. Yes, developed countries have come up by releasing maximum number of, maximum amount of gases, etc., and now they are stabilized, but still they go on increasing the burden of the greenhouse gases in the atmosphere. But we being the developing country, we also need industrialization, therefore we go on also increasing. So therefore there is a pressure over developing countries that you should stop, say for example, paddy cropping, you should stop generation of methane, and you should stop something that, other like that. So this is just an example of how much is the contribution towards the radiative forcing. Radiative forcing means how much radiation you are generating because of the anthropogenic activities. So radiative forcing can be measured in watts per meter square, something like that. So that means how much energy is being generated in the atmosphere because of the anthropogenic gases. So you will find that actually we are not a big source of all these radiative forcing, but still because of the high population, if you just look at it seems to be higher, but per capita if you calculate, we are far below as compared to any developed country. Next please. So this is some certain facts that world average per capita greenhouse gas emissions, including say land use, land cover factors, etc., we are 6.3 tons of carbon dioxide equivalent. Okay. So what people do actually globally, while they calculate the burden of greenhouse gases or various types of greenhouse gases, they convert it into carbon dioxide equivalent, because carbon dioxide is a major gas. As I told you, 64% contributes to this one only. So that if we just look at that, India remains far below the world average of 2.4 trillion carbon dioxide equivalent. Okay, but because of the high population, etc., people think that we are contributing more towards the carbon dioxide. So emissions of India are about half of the G20 average. So that also you can compare. So it is not so much, but that doesn't mean that we should not control the greenhouse gases, we should not adopt the best practices. Next please. So this is the result. Because of this increase in greenhouse gases, you will find that since 1880, that is the beginning of the industrial period roughly, you will find that there is a continuous exponential rise in the temperature. You can see the red line, how much rise is there. Now you can say, okay, temperature was falling, the natural trend was falling, and now you have got the rising trend. That means we are going against the nature. It could have fallen, but it is rising because of the anthropogenic activities of human beings. Next please. So how much is the rise? Rise is 1.15 degrees Celsius for 100 years for globe as a whole. You will see what is that. There are only 1 degree Celsius. Yesterday, for example, temperature 38 degrees Celsius, today 39 degrees Celsius. I don't find much difference in Delhi. 1 degree rise. In the globe, there is 1 degree rise only. Why so much hoala? Why we are so much worried? Because it is the average temperature of the globe has risen by 1 degree Celsius. I told you average temperature is 15 degree. In 15 degree, there is a rise in 1 degree. When there is 1 degree Celsius rise in average temperature, if you compare a particular country, or a particular state, or a particular station, there will be more rise. There could be 3 to 4 degrees Celsius rise or 5 degrees Celsius rise if you consider the individual stations. So therefore, we should take into consideration in that manner. Now if you compare similarly land and ocean, the rise is more in land surface. You can just find here, there is rise, how significantly it is rising. Red curve is the land surface temperature rise over the globe, and the blue curve is the surface rise temperature in the ocean. So we may be happy that ocean temperature is not rising much. We will go and stay ocean. No, it is not so easy. You should remember that water has the maximum heat capacity. So heat capacity of water is 1, if you remember. So now, even if you have got say 1.5 degrees Celsius rise over the ocean, if you measure the ocean heat content in the upper surface of the upper surface of the ocean, it will be huge. So what happens then? So since it has the high heat capacity, it does not cool down. If you go to Rajasthan in summer, during daytime it will have 45 degrees Celsius, but at night it will go down. So there is high diurnal variation, therefore you will not feel that 45 degrees Celsius continuously. But in ocean, be it day or night, you will have the same temperature. It does not show diurnal variations. because heat capacity is quite high. It does not change day to day. It continues, higher temperature will continue for days together. Unless there is some cyclone depression comes and then temperature will go down, other temperature will not go down. Or unless otherwise the sun moves with respect to Earth, like that. So therefore, we should be worried about the rise in ocean content or ocean content, ocean temperature. There is another reason also I will tell you what happens actually. If ocean temperature increases, there will be thermal expansion of water, Charles' law. If temperature increases, the volume increases. So sea water is expanding, ocean is expanding. So therefore, rise in sea level. Not only that, because of rise in temperature, the ice cap will melt, glacier will melt, snow cover will melt. So all these will add to the water volume of the ocean. So if I measure, it is about 90% coming from the melting of the snow and ice, and 10% coming from the thermal expansion of water. So therefore, it is worrisome that ocean temperature is rising. Another point is that once ocean temperature rises, ocean is a sink. Ocean can absorb carbon dioxide. So when it is absorbing carbon dioxide, what happens actually? If you take a pure water, what is the pH value of water? pH value, do you remember? To measure the acidity and basicity of water, it is 1. Or how much? pH value? I told you 1. 7. Okay. So if it is less than 7? Acidic. Now if you go on increasing the carbon dioxide in the atmosphere, where will it go? Ocean absorbs those carbon dioxide, the ocean becomes more acidic. So entire aquatic life is threatened now because of the acidic behavior of the water. At the same time, our industry, if you look at, for example, India, the most important exporting industry, can you tell someone can tell which one is the most export-oriented industry in the country? Huh? Not beef, fish. Fish. And this is marine fish. Okay. So what will happen actually? Your fish industry, so it is under threat. It will be under threat if you go on increasing. Already I will tell you, earlier we provided fishermen warning for the coastal belt up to 50 kilometers. And fishermen are expected that they will go up to 50 kilometers only, not beyond that. But nowadays people are not limited up to 50 kilometers, they go into deep sea. Why? Because fish are not available near the coast. Why fish are not available? But just like we are putting here in the AC environment, fish also wants to stay in AC environment, that means cool water. And they are not getting cool water near the surface because temperature is rising, sea surface temperature is rising. There is marine heat wave conditions in Bay of Bengal. So therefore fish also migrate towards the deep sea, in deep water. So to catch them, now the fishermen are moving towards the deep sea. So therefore from 2018 onwards we are providing entire warning for the entire North Indian Ocean, Bay of Bengal, Arabian Sea. So that wherever you go there is a warning at least. Otherwise, so it is a good thing that no fisherman dies nowadays because of the severe weather. So whatever it is, I want to say, I just want to highlight that we should not be satisfied that, okay, we can go on releasing carbon dioxide, we can go on cutting the forest, we can go on industrializing, we can go on increasing urban population, and don't worry, ocean is there with us and it will absorb all carbon dioxide. No, it is not helpful. Next, please. And global temperature trends, you can see like that, northern hemisphere, southern hemisphere. Northern hemisphere is more rising, southern hemisphere is less rising because northern hemisphere is more landlocked. Southern hemisphere is more ocean, therefore it is a reflection. But actually I will tell you, please take care of both atmosphere and ocean. Don't worry about only atmosphere or the land surface. Next, please. Yeah. Now, why the climate change? Now, I have shown one diagram that how temperature was naturally, it was decreasing. Now from 1880 onwards, temperature is rising. There is another factor here. You can see that the curve, the yellow curve, you can just look at, it is going down. That means incoming solar radiation. This is the presentation of incoming solar radiation. Incoming solar radiation is decreasing over the years. At the same time, the surface temperature of the earth is increasing. So who is causing it then? The sun is the ultimate source of energy. Because the sun only, earth is getting heated. Therefore, whatever temperature is rising, it may be because of the sun only. But now I am finding that it is not. Sun is telling, no, I am not heating you. I am reducing. My energy towards earth is reducing. But even then your temperature is rising. That means I am not doing. You are doing yourself. Okay. So you are responsible for yourself. Just like God says in Karma Yoga. So it is like that only. So what is this phenomena? This phenomenon is called as solar dimming. Here is the phase where dimmed light, you remember, when the power ठीक से नहीं आता है तो dim light होता है. So like that, solar dim phase is going on. Okay. Now temperature is not increasing because of the sun. It is because of the anthropogenic activity of the human beings. Next, please. Okay. So how do you measure this climate change then? As I told you that there are byproducts, we measure all this climate change by measuring the weather. And to measure the weather, we have got three-dimensional observational systems like satellites from the space, radars for the atmospheric phenomena from the surface of the earth. Then we have got the balloons released every day with the hydrogen gas or helium gas. In the balloons, there will be sensors like thermistors, agistors, barometrics, etc., to measure the temperature, pressure, winds, etc. And these are GPS based. When the balloon is released, it is followed by the GPS. So you can find out where the balloon is. By tracking the balloon, you can find out what is the wind speed and wind directions. The balloon is filled with gas in such a manner that it will move along the wind speed and wind direction at a particular point. That means you can measure indirectly the wind speed and wind direction by following the balloon. Initially, when we started, at that time there was no such balloon, it was kite. Okay? By following the kite, when this flight started, actually before Second World War, when it started, it was kite only. By following the kite, people what they do, actually they just put a kite, by climbing the tree, they put the kite. So when kite will be moving towards that direction, you can find out. But now also if you go to the airport, you will find that there will be a sack in the middle of the runway. It will be moving towards that direction, you can find out what is the wind speed, what is the direction, you can estimate from that sack itself. Now gradually that kite was replaced and balloon came up, and balloon was released and followed by the theodolite, optical theodolite, then came the radio theodolite, now came the radar, and then came the sensors, and now we have got sophisticated systems to find out every second with the GPS, all the sensors, all the data up to a height of 35 kilometers. Can you imagine? And twice a day we take these observations, sometimes 4 times a day if there is severe weather conditions. But that gives you the vertical profile of temperature, wind, humidity, pressure, everything. At the same time, at the surface, we measure it with the help of various types of observational network. Okay, we have got automated weather stations, we have got radar, we have got wind profiler, we have got micro radiometer. All these informations are increasing day by day, providing you a lot of information about the current status of land, ocean, and atmosphere. Why? Why are you doing like this? Because if you want to predict this weather and climate, you need the initial condition of the atmosphere. The science is nonlinear, and if you are from mathematics background, a nonlinear equation cannot be solved directly. It has to be approximately solved. Therefore, when we say that, yes, it is likely, rainfall is likely, it is not we. Throughout the world, people say with probability, because the system is nonlinear. Deterministically, if I tell you it will rain today in Delhi, I may not be 100% correct. If I tell you that there is a 60% chance that it will rain in Delhi today, I will be 100% correct. Okay? So at the same time, the user can utilize this information. So this is the problem of the science. Okay? There is limitation in the science, and it is called as initial value problem. If you have the very good initial informations, just like you solve the mathematical equations when it is nonlinear equations, putting up the Fourier transforms or Laplace transforms or the Lagrange polynomial or the different types of Legendre polynomial. Here also we utilize that, fitting of the polynomials with the global modeling systems, and we address the various dynamical equations like Newton's law and thermodynamic equations, what we have read. I told example of Boyle's law, Charles' law, etc. Gaseous equation, also utilize that. So all these equations what we have studied in the childhood, that we are applying here. Basic equations. But in the basic equation, there are many types of interactions. And these interactions are addressed and they are parameterized. And accordingly, models are run with the help of the high performance computing system. You will say it's a very simple equation, Newton's law. Why you are not able to solve it? No, you cannot solve this Newton's equation. When you calculate, really, it becomes the very nonlinear differential equations considering the various types of forces. Simply, this rate of change of momentum is equal to force. But what are the forces? There are various types of forces. You have got frictional force, you have got centrifugal force or centripetal force. Then you have got the Coriolis force, you have rotation of the earth around this one axis. And there are pressure gradient forces. There are many forces. So together all these forces are leading to the change in momentum or the equation. You are finding the solution for the wind velocity or wind directions. And similarly, there is a equation for continuity to define how wind or air, you can say, it is a continuous fluid. So therefore, to find out their characteristics, we have to go for nonlinear equations, and these are defined. Over the years, it has been defined, and they are being solved with the help of the high-performance computing system. Simple computer will not help you. You can imagine we have a computer what we have, that is 28 petaflop machine we have got at present. Petaflop means 10 to the power 15 floating point operations per second. That means if you are doing addition, subtraction, multiplication, division, 10 to the power 15 times in a second. And with that, what observation we take in the morning 5:30, we solve the equation, run the model, we get the output as a forecast for next 10 days by 9:30 for the globe. Can you imagine? So that is the chamatkara buliye. The human society has been able to address the understanding of the nature and to predict the nature. Gone are those days when you say that yes, it will not rain, you told it will rain, you carry the umbrella, or opposite. But now, if you look at, yes, our forecast is reasonably accurate. I am not tell that it is 100% accurate, but over the years, the accuracy has improved by 40 to 50% in the last 10 years. Next slide, please. So these are the indicators of climate change. Go on up. Jawat rahiye. So if you just look at that, you will find the glaciers are melting. Yeah, temperature over land is rising. The snow cover is falling. And also like that, there are many factors you will find that which are indicator of the climate change. So when you talk of the IPCC, Intergovernmental Panel on Climate Change, it is an intergovernmental body. Every country provides the information. We also provide these informations every year. The statement on the climate change is issued by India Meteorology Department every year in month of January. It is published in the press release and also goes to World Meteorological Organization, goes to IPCC through Ministry of Environment, Forest and Climate Change. And that provides a statement whether and how much the climate has changed during past 100 years or past 30 years or past 50 years, whatever observation you have. And that information also depicts what has happened to the extreme weather, what has happened to, say, for example, heat wave, what has happened to the cold wave in different parts of the country. And all these are taken into consideration, and globally a statement is prepared by WMO, and that goes to IPCC. At the same time, also we run the models. That is called the Earth System Model. We have got Earth System Model running in Indian Institute of Tropical Meteorology in Pune, that is in Ministry of Earth Sciences. It provides what is going to change for next 50 years, next 100 years, or next 30 years. So all these things are carried out. So these are some of the output I am showing you here. The oceanic content, how much is increasing. There will be uncertainty. There are around 20 models being considered throughout the globe to provide you what is going on in climate change, Earth system models. So like that, when day-to-day forecast we provide you, it is based on 6 to 7 models. So there are uncertainty in the models. To take care of those uncertainties, number of models are run, probabilistic approach is adopted, and information is provided to the public. Okay, next please. So like this, there are some of the indicators like say how much glacier is melting in northern poles, southern poles, etc. But I will tell you, globally, average precipitation over land has increased or likely to increase with the impact of climate change. There is increased precipitation in many parts of the world. But what happens in India? There is no change in monsoonal rainfall over the country as a whole. We are blessed. In spite of all these changes going on throughout the globe, Indian monsoon during 1st June to 30 September is almost same. Only there is 10% variation year to year. Okay, so by that way we are blessed. Entire water, I am talking about entire water for the country as a whole. But if you look at different parts of the country, rainfall is increasing over West Rajasthan, Saurashtra, Kutch, that is drought prone area is now getting more rain, and rainy area like northeastern states and adjoining Bihar, East UP, Jharkhand, somewhere in West Bengal, rainfall is decreasing. Okay, so there is some kind of bipolar behavior which is developing because of the impact of the climate change, but total amount of rainfall remains same. Therefore, here is a clue. If you can manage the entire water for the southeast monsoon season, then you should not worry about. Okay. Similarly, when you go for the day-to-day rainfall activity, the frequency of extremely heavy rainfall activity, say 15 centimeter or more, are increasing. But light rainfall days, moderate rainfall days, say 1 centimeter, 2 centimeter rainfall in a particular day, that is decreasing. Therefore, when you go to the villages and go to listen to the people, they will say that earlier it was raining together 7 days. Nowadays it is not raining, and when it is raining it is a downpouring. Yes, that is true. It has happened like that. Okay. So now what is to do then? What should we do then? This is the impact of the climate change. We should learn how to harvest water, how to harvest rainfall. If you can do that, whatever this unevenness has developed over the years, that we can take care of. Otherwise, the people like in Cherrapunji, you know, this is the rainiest place, the Cherrapunji, Mausunram, we get rainfall, highest rainfall in the globe. But if you in the summer, you will purchase the water bottle. Okay, so this is the fact. So we have to learn how to harvest the water. So these are some of the facts I put up here. Heat wave frequency is increasing and will increase, duration, intensity also. Cold wave is decreasing because temperature is falling, so cold wave is decreasing. Frequency of cyclones are not increasing, it is decreasing. But intense cyclones are increasing. In Bay of Bengal, there is no change. In Arabian Sea, intense cyclones are increasing since 1990. So like that, floods and droughts are increasing even though total amount of rainfall remains same. Chaliye next. So this is just an example what is happening in India. Against 1.15 degrees Celsius rise in temperature of the globe, in India temperature rising by 0.67 degrees Celsius. Okay, but we should not be so much complacent. Say in India 0.67 degrees Celsius rise is quite significant because India is a tropical country. If you look the rise in temperature, you will find that rise in temperature is maximum near the pole. But that doesn't mean that pole is becoming, but rise in temperature here, already temperature is about 35 degrees Celsius in India. If temperature is rising here even 0.67 degrees Celsius on a particular day, if you take in one stations, there it can be significant rise in temperature. So therefore 0.67 degrees Celsius rise in temperature is also quite significant. And this rise in temperature is maximum in the post-monsoon season and winter season also. But also there is rise in temperature in monsoon season and also in summer season. So what happens? There is another impact of this rise in temperature. When temperature rises, the water vapor holding capacity of the atmosphere increases. Water holding capacity of the atmosphere is increasing. So at present, because of the rise in temperature, we are feeling more hot. Then humidity is increasing because water holding capacity is increased. So what happens? The discomfort, which is a function of the temperature and humidity, is increasing. We are feeling more and more discomfort. So this, with the same temperature, for example, 45 degrees Celsius in Delhi, if people are not dying, now with 45 degrees Celsius, with rise in humidity, people will die. So therefore, there is a need to address this requirement that we should give the forecast of humidity. That we realized, we started giving forecast for humidity, temperature, and combined impact of the heat and humidity. So like that, there are various factors which are also changing, that is taken in a composite way. You cannot address in one way only. So here we want to say that there is also rise and we are facing all the problems what we have discussed earlier. Next please. Yeah, this is very alarming. You can see that in most parts of the country there is a rise in temperature. Okay, there is a rising trend. This red color indicates the rising trend. Most parts there is a rising trend in temperature. It is not simply the all India temperature rising. Different parts of the country also temperature is rising. Next please. Yeah, this is red one is the rise in heat wave conditions and blue one is the fall in heat wave conditions. What you find in the left hand side diagram, you will find that many parts of the country the heat wave frequency is rising. Okay, and the right hand side if you see that the blue curves are, that means temperature is not falling, it is rising. The cold wave conditions are reducing over the country. Next please. This is the monsoon condition I have discussed with you. There is no trend. This is the past 100 years data from 1901 onwards. You see, there is no trend in monsoon. It's just internal variations, sometimes becoming higher, sometimes becoming less, but there is no trend. Next. Yeah, this is the floods and droughts. You see, the total amount of rainfall is not increasing for the country, but number of flood years are increasing, number of drought years are also increasing. How is it possible? Those who are from statistics background can understand this. With the same data set, if variability is more, if the standard deviation is more, then you can have the extremes. So that is happening. Floods and droughts are the extremes. Because of this high variability, earlier rainfall was also variable, but it is more varying now. Because of that, we are getting increase in frequency of floods and frequency of droughts. Next please. SPI is the standard precipitation index utilized in drought estimation. Next. Okay, as a previous one was the cyclone case, I told you. Globally also number of frequency of cyclones are decreasing, but intense cyclones are increasing, like extremely severe cyclone storms. Here also in India, we also find the same thing. Okay, so there is impact on extreme weather. What I find that frequency of extreme weather is increasing globally because of the climate change. But luckily, you will find globally the number of deaths which are occurring earlier, that is decreasing. Because of what? So because of the improvement in early warning system. Early warning system plays a dominant role which can trigger the early actions and you can take preparedness measures and prevent the casualties. Okay, next please. So this is what I want to say, that climate system instability. Because of this, our system has become unstable. The carbon dioxide affects the acidity, as I was explaining to you, negatively impacts the coral reefs and planktons, and hence the food chain in the ocean. May also affect the carbon cycle. Carbon dioxide helps plant to grow, but quality of yield still is reduced. You will be surprised to know that the yield of the rice is expected to decrease. The yield of wheat also expected to decrease. I'll show the next slide. Okay, next please. So what happens actually, if there is a 2 degrees Celsius rise in temperature, which is expected that by 2050 perhaps will 1.5 it became last year itself, and that warmest year was last year, 2024, and it is going on increasing by 1.5 degrees Celsius. At any time we can expect 1.5 degrees Celsius. But if it becomes 2 degrees Celsius by 2050 or so, there could be 60% decrease in wheat yield in subtropical areas. So what's a subtropical area? Like say UP, Punjab, Haryana, these are called as subtropical areas. Okay, there could be 17 to 18% in tropical areas. That means if you are cultivating wheat, say Maharashtra or Odisha or Chhattisgarh, Madhya Pradesh, there can be 17 to 18% decrease. For rice, actually, yes, there could be an irrigated rice will be maximum sufferer, and there could be 10 to 18% decrease. So sensitivity of the monsoon, I'll give one example. Rainfall was deficient by 19% in 2002. Our gross domestic product gone down by 3%. You can imagine how important is the weather and climate. If you are playing with this, how it can be devastating on our socio-economic activities. Next, please. So these are the climate change and food security. You will find that this is an international organization, FAO. They have reported that 26.8% total population are associated with agriculture, forestry, and fishing. Large population are dependent upon this. And all these three, agriculture, forestry, fishing, depends upon weather and climate. And climate change, therefore, can have huge impact on all these things. Simply, agriculture contributed 4.2% of world GDP in 2018, for example. I've just written here. So like that in India also, agriculture plays a dominant role. Now also 60% of population depends on agriculture. At the same time, I will tell you, we have got a large area where you do not have irrigation facilities. Irrigation facilities is less than 40% in the country. So therefore, still we are dependent on the rain god, rain-fed areas, and especially the central India and the adjoining areas of North India and peninsular India, where you do not have sufficient irrigation facilities. So therefore, they are dependent on rain-fed. So rain-fed agriculture will be most affected, and also the irrigation affected also will be there, because I will tell you the reasons. When there will be rise in temperature, demand for power will increase. So many things, so they are all chain. So everything will be affected because of that, and therefore there can be impact in irrigation land, also non-irrigation land. Land, who are the worst sufferers actually? Poor is the worst sufferer. Landless laborer is the worst sufferer. Poor farmers are the worst sufferers. Small vendors are poor sufferers. For example, the street vendor, you go sometimes, आप जब पानी पूरी खाते हैं कि आप जब सब्जी खरीद करने जाते हैं, आप जब फ्रूट्स खरीद करते जाते हैं, देखा है कभी कभी आपने तो एसी कार में जाते हैं. I felt very bad one day. I was just moving, sometimes I just walk in the local market. One person came in the family, sitting in the car. It is AC car. They stopped near that pani puri wala. Pani puri क्या बोलते हैं यहाँ actually दिल्ली में क्या बोलते हैं? गोलगप्पे. गोलगप्पे. He stopped the car there, but he did not stop the car. माने mechanically car is stopped. AC is on. All the exhaust from the have you stood sometimes near the AC car? So much heat energy comes out from the car. All these exhausts are coming toward the face of that shopkeeper, and he ordered, you give me bus 20 rupees only 20 rupees, and he gave you golgappa. You took the golgappa, you were happy, and you were consumed in a cool environment. What happened to that particular person? We did not imagine actually what harm we are doing to the society. Is it 20 rupees sufficient for that particular person? Can you reduce the temperature on which he is standing there and providing you the golgappa? And similar is the case with the street vendor. In the hot day, he is selling the food, he is providing the sugarcane juice, etc., and he will be sweating. And you go in. So you should also understand the darad kya hai, दूसरा लोगों का हम दर्द समझना चाहिए, how the landless farmers are suffering because of us. So therefore, we can do something huge. Therefore, I track the capital. You can do a lot to help the poor, help the landless laborer, the street vendors, and entire globe. How can we? Next, please. Next. Okay. So these are the projections. Projection says that yes, they will rise. How these projections are calculated? The projections are calculated based on the socio-economic pathways. It is called as SSPs. Okay, socio-economic pathways. Say, for example, I will assume that no, Delhi will be like this only. There will no increase in concrete structure. There will no increase in population. There will no increase in vehicles. So that will be business as usual. Or I can say that no, our economy is improving. Number of vehicles will increase like this. Number of roads will increase like this. Or activities will increase like this. And accordingly, you can go for SSP1, SSP2, SSP3, SSP4, etc. And all these activities are contributing towards the increasing radiative energy in the atmosphere. Accordingly, we calculate RCPs, radiative concentration pathways. RCPs are dependent upon the SSPs. And that RCPs say that, say for example, it will increase 2.5 or 4.5 or 8.5 radiative forcing. Then accordingly, what will be the temperature rise? And at that time, what will happen to various types of extreme weather, what will impact on the ecology, what will impact on our surroundings. All these things are calculated, and these are given as IPCC report. Next, please. So this is the finding of our Earth system model, which we run in Ministry of Earth Sciences. It is showing that yes, under these warming conditions, there will be rise in temperature in India by 2.7 to 4.4 degrees Celsius, say by example, say 2070 to 2099. So like that, there are various projections for the surface temperature, sea surface temperature, rainfall, etc. I have just shown example of atmospheric temperature and sea surface temperature of the Indian Ocean. Next, please. So here you just see actually what will happen to monsoon rainfall. If temperature rises, what will happen to monsoon rainfall? As a guess. As a guess, we just see if temperature rises, what will happen to monsoon rainfall? Monsoon rainfall occurs because of the convective process. More the heating, more is the evaporation, and hence more is the moisture content in the atmosphere, and more instability, and hence more rain. Very simple. Water cycle will be activated. So therefore rainfall will increase. But the fact is that over the years now, rainfall has not increased in India. Okay? So that means there are something else. The models are not able to capture. But however, it shows projection. Therefore, projection has to be taken with a pinch of salt. It's not that it is a projection. It is not prediction. It is a projection. It is based on certain assumptions. And these assumptions, as I explained to you, it may not be correct. Say, what shall I do tomorrow? I will not tell you. And it is very difficult to guess the human mind, to guess the human society, and find out the projection for the next 50 years. So whatever it is, because of that, the model projections are also not so correct. Next, please. This is the model projection, for example. It is showing that there will be rise in temperature, but actually if you see the data of 1950 and 2014, and if you compare the forecast, you see the compare. The first of the right-hand side, India, and middle one, India, you see, is there any similarity? There is no similarity. There are certain differences. So therefore, you should not believe always these such high projections of 15 years, 50 years, 100 years, etc. But still, you have to plan for the generations. You have to think of the generation. The fact is that yes, it has happened to some extent. Even the monsoon rainfall has not changed, but frequency of heavy rainfall has changed. Temperature is rising. Heat wave is increased. Cold wave is decreased. Heavy rainfall frequency is increasing. Heat wave is increasing. Thunderstorm is increasing. Lightning frequency is increasing. These are the facts. So therefore, we have to accept yes, climate has changed. Next, please. Okay. So how much climate has changed and what will happen to that? I'll just listed it there, but the time is short. Actually, I got late. Otherwise, I could have spent more time with you. So what you see that if there is a temperature rise of, say, for example, 1 to 2 degrees Celsius, what happens? Major impacts on ecosystems and species, wide-ranging impact on the society, including developing country agriculture. Okay. So like that, if you look at the temperature 2 to 4.5 degrees Celsius, West Antarctic ice sheet collapses. Now also, if you go to Greenland, it is now becoming a divide of ice only. If you go to Greenland now, no, ice content has decreased significantly. And now, therefore, it is also helping something. Like Russia, for example, there will be another waterway. Okay. So now the new route for ships will open and new business or industry will open up. Now, Russia will be benefited. Norway will be benefited. All these countries, Sweden will be benefited. Those who are on the northern side, because there will be new waterways. Okay. So like that. Next, please. So there are various climate change science aspects I have discussed so far. Now comes the adaptations and mitigations. So what will you do? भाई हो गया तो हो गया, जो हो गया तो इसको adapt करना पड़ेगा. For example, now we tell that monsoon onset dates have changed. Earlier, we told that monsoon covers entire country by July 15. Now monsoon is covering entire country by July 8. And this year it is covered by July 1st or something like that, early onset. Then we told that monsoon is getting delayed in withdrawal from Rajasthan. Earlier monsoon withdrawal started from 1st September, now it is starting from 19th September. That means duration of monsoon has increased in northwest India. At the same time, duration of monsoon same in the South Peninsula, duration of monsoon is decreased in central India. So now a farmer, what will he do? Now he has to adapt it. He cannot say that, no, you have to adapt. You have to go for this type of paddy or this type of wheat or whatever it is, which can adjust to the changing environment. So that is called as adaptations. These adaptation mitigations are not independent of each other. There are many gray areas where they are common, just like two sets. And there you can see common sets like that. So A intersection B, you can see find out here, that area, for example, buildings, etc., green infrastructure, etc. These are common for adaptations and mitigation. There are many ways to adapt and mitigate. One, for example, is that urban sectors. So we can go for all these practices which is sustainable, which is environment friendly. We can adopt the renewable energy and phase out the coal-based energy. So like that, there are many such. I told another example, water harvesting. Another example is a polythene or the plastic. We can minimize the use of plastics. Transport, we can minimize the transport. It is a hobby for people to purchase one car after the another. Say for example, let us take a place, we can travel on Sunday. We will not use the car. Or for example, if market is within 1 kilometer, I will never use the car. If my office is within 1 kilometer, I will not use the car. So by that way, or I will use the mass transport, I will not use the individual car. So there are many such ways by which you and I can contribute towards adaptations and mitigations. Next, please. So these are the sustainable development goals. It is fixed by Sendai framework in 2015 with a target of 2030. You can now assess yourself how much we have achieved so far. But target was 2030 sustainable development goal. One is we say right to life, livelihood. All these things are there actually. All these sustainable 17 goals are there. But most important goal is there, the climate actions. That is goal number 13. I just want to say the climate action. It was told in 2015 that we have to go for climate actions to save the earth. So what are those climate actions? So we have to enhance the observational systems, the early warning systems. We should take the actions as mandated in UN framework for Convention on Climate Change, UNFCCC. It started in 1992 actually. Everything started in 1992. Therefore we came up with the Kyoto Protocol. Those who tried for various exams before entering into the job, they might be knowing. You might have read all this in GK. So when we started all these things, initially we came with UNFCCC, then we came up with say Kyoto Protocol. Now finally we come with the Sendai framework. Now we have the Conference of Parties, COF. Okay. So all these things are the policy decisions taken at the global level, UN level, and which is supported by the regional policy and the national policy. In the national policy, the policy changes with the change in politics also. Whatever it is, but there is a policy, and policy is being addressed. And then going down again, say for example in our country, we have got the plans, national action plans, under Prime Minister's 10-point action plans, then also goals. Then we have got the state action plans. We have got the state level climate cells now. Then we have got the district. And finally, the tehsil, block, village, and the individual. But there is no such plan for individuals. The individual has to adopt the different plans as per their wish. Next, please. So national action plan, this is the just list. I think all of you know the national action plan. Like first one is the ensuring energy conservation and improved energy efficiency. Then second one is the promoting renewable energy. In the few days back, you might have read the paper that we have achieved the target. Already we are exceeding the target towards the renewable energy. So it is a good thing. We are moving towards that directions which can ensure us a sustainable environment. Similarly, there are many such 10 points I have written here, including the clean air programs, etc. Next, please. So these are the missions. Based on those action plans, the missions we are taken off. One is the National Solar Mission. That's what we are following up. Then we go to the National Mission for Enhanced Energy Efficiency, National Mission on Sustainable Habitat, National Water Mission. So like that goes National Clean Air Mission also, NCA-F also, Clean Air Program. So all these things are taken up, and there are various nodal agencies fixed for that. And we are responsible to provide the detection and prediction of the climate change, what is occurring. And policy plans are taken care with Minister of Environment and Forest and the climate change as the nodal ministry. Next, please. So one of the most important thing I will not discuss all the points. One is that disaster risk reduction. Because of this climate change, there is increase in disaster. We found that. Number of deaths have reduced because of the intervention of the disaster management policy, act, plans, guidelines, institutional mechanism, and country India is far ahead in all these aspects. And we have got everything in place with respect to response, relief, post-disaster, pre-disaster, during disasters, everything is in place. But all these things what you find actually, one player is there who does very important role. That is called multi-hazard early warning system. In any phase of the disaster management, you need multi-hazard early warning. And IMD is responsible for providing multi-hazard early warning for the weather-related disasters, not with earthquake. Earth is not ours. Similarly, floods within ours. But most of the weather-related disasters like tropical cyclones, heat waves, cold waves, heavy rain, thunderstorms, lightning, snowfall, we are responsible for that. Next, please. So this is the case in globe. Now I will say in the 50% of the country, there is no early warning system. Just imagine how lucky we are. We have an early warning system in the country, and 80% of people have the early warning access in our country. Just think of the poor countries like say Maldives, countries like Sri Lanka, or countries like Bangladesh, or countries like Yemen, Somalia, so many poor countries, least developed countries, island nations, even developing countries, they do not have the early warning system. If you do not have early warning system, you cannot manage the disasters. Because you cannot change the house of a person. If somebody has a mud house, one night you cannot change the mud house to Pakka house. What you can do? You can provide him the warning. Say tomorrow there will be heavy rain and this house may collapse. So he will escape from that house. He can go to cyclone shelter, or he can go to his neighbor's house, or he will be saved. That is called as early warning. So therefore, early warning is the first and foremost step. Globally, therefore, every country, every policymaker tries to improve the early warning, because it is not so possible to change our preparedness measures based on the infrastructure improvement. But it is a slow process. Infrastructure should change. For example, we have taken many initiatives like say Pradhan Mantri Awas Yojana or something like that. Many houses are now Pakka Ghar. Okay, we do not have mud houses now, but still we have got mud houses. We have to go towards that. Similarly, the electricity, it is not underground. It is just hanging wires. When there is a tropical cyclone, they will be just devastated. It will cause deaths. It will cause damage. So there are many such ways in which we can adapt and we can reduce the disasters based on this early warning. Next, please. So this is the integrated early warning system of India, Meteorological Department, multi-hazard early warning system for disaster risk reduction. It is a chain. It starts with observations, then you go for collection of data, communication of data, integration of data in a platform that is called decision support system. At the same time, data goes to high performance computing system where it is processed, models are run, model output comes up into again that decision support system. In the decision support system, now you have got the observational data, you have got the forecast data from the models. Now this is the role of the forecaster. He has to compare, comprehend, analyze, take a decision in objective manner to give the final forecast. When we give the final forecast, it is not a simple forecast, it is the impact-based forecast. That means we say what the weather will do tomorrow instead of telling simply what the weather will be tomorrow. If I simply say that, yes, it will rain tomorrow, how does it matter? If I say that it will rain tomorrow so that transport or traffic will be held up, or such and such slum will be inundated, that is called as impact-based forecast. And from 2019, we have introduced the impact-based forecast at district level and of course the city level. Now, so what I want to say is that the information at present which is going from IMD, it is just like a ready to move house. You don't worry about that. Simply read the bulletin and you can find the solutions and take the actions. Okay? Or just like you don't have anybody, you just call the mill and you will get food and take the food. So you do not worry about purchasing sabji, taking go to the keys and all these things. So this is what is called as the impact-based forecasting, risk-based planning. But while doing that impact-based forecasting, risk-based planning, we cannot do it alone. We take the help of various agencies because you need data on the society. You need, if you want to give the inundation forecast for Delhi, you should know what is the drainage system of Delhi. You should digital data of drainage system. You should the data about the roads, bridges, culverts, railway stations, metro stations. You should data about type of houses. You should data on the slums, digital data. And this digitization of the data in the recent years is helping us, and we have started. Cyclone is a complete story. Every village impact forecast warning is evaluated. For district-wise information, we have the heavy rainfall case or the heat wave case, cold wave cases. We have to go a long way in these directions, but we have made a beginning, and it is helping to minimize the losses. Next, please. This is called the impact-based forecast. You can see this color-coded information we are providing, and like this, it goes on, and it very specific information are provided for different cities and towns. And at present, we have come up with a Mausamgram. I will tell you, I will request all of you, please download Mausam mobile app. In the Mausam mobile app, go to Mausamgram, and there you can be very happy to inform your villages, wherever you have come from. They can find out what is the forecast. Or if you want to say, okay, I will tell you the forecast of your village, okay? So you can write the name of your panchayat, you will get the forecast for next 10 days. Write the name of your block, you will get a forecast. Write the name of Tahsil, you will get a forecast. Write the pin code of your area, you will get a forecast. You can get the forecast of NCA-F if you write. Okay, I don't know whether you have seen it or not, but please try. You will get the forecast for this particular area. Okay, so we have gone up to panchayat level. Now target is that Har Har Mausam, Har Ghar Mausam. Each household should have the access to weather and climate information. Each household should be warned so that they can utilize this information to safeguard their life and property, and also they can improve their socio-economic conditions. Next, please. So therefore, it is a revolution. It is a movement where we need the participation of the people, also organizations and remote sensing agencies, ISRO, etc. Many people are involved in that. We are doing that. How the people is involved? Say, for example, I told that it will rain in Delhi, and you say that it is not raining here, or you saw that we have not told that it will rain, but you saw that it is raining here. Please go to our public observations website or mobile app. There you write, it is raining. Simply you tell it is raining. We will take care of where it is raining now. It is GIS based, GPS based. We can find out it is raining in NCA-F. Okay, and that information will help us to validate our model. Our model forecast accuracy will increase. We can improve our model. Number one. Number two, if it is raining here, I will say Chhatrapur may get rain here. After half an hour, Chhatrapur will rain. Okay, so your information can help the other public. So this is called as the citizen science. We are moving towards direction where it is citizen science. Every citizen will be empowered, and also every citizen will be a participant. It is a participatory role of citizen to provide information in a scientific way. Nothing to do. Only you try to it is raining, or it is lightning, or tree has broken because of the wind. Again, you can take a photograph also. You can upload the photo also. We will take care of that. So science has come up to that particular stage. I request all of you, please be a partner, be a citizen scientist, and contribute towards the development of the society and help people to minimize the losses and improve the economy. Next is a future trend. The role of individual, I will just tell you. The future trend is this one, AML. Everybody talks of AML. We are utilizing also AML. And it is a mission Mausam, which is declared by Honorable Prime Minister on 15 January 2025. It is a very ambitious mission where we are planning that Har Har Mausam, Har Ghar Mausam by 2047. It is just creating a base for 2047. And our target is that we have to go for 126 radars. Now we have got 40 radars. So that there will be no area which can escape from radar. There will be no severe weather which can escape from radar. At present, some thunderstorms, lightning, squalls, hailstorms are escaped by IMD because we do not have observations. So there will be no escape. Everything will be detected and hence predicted once we have got that radar systems. And target is next 2 to 3 years. And forecast accuracy will improve by 10 to 15% by 2030. So with this target, we have prepared our future plan and vision and strategy. Now, if you look at the individual, what an individual can do. See, as I already have explained all these things, you can manage the water. You can avoid the wastage of water. You can approach the sustainable agriculture. You can go for energy efficiency. You can go for sustainable transport. Pollution you can control. And there are many, biological. also you can do. There are so many things where an individual can interfere and intervene. Next, please. Yeah, let us take what you can do, role of individual. You can minimize sources of greenhouse gases. Do you know how? How can you minimize? Say, for example, if you stop using polythene, you can minimize the greenhouse gases. For example, if you stop cutting the trees, you can minimize. If you stop traveling in your car at least one day, you can minimize. So best way is that I will request all of you, please go to Google and you calculate your carbon footprint today. And after 1 month, you calculate your carbon footprint. Then you can find out whether you are really reducing the carbon or not. How will you do that? Because you have to be truthful. You have to tell what is your food, what is your cloth, what is your shelter, what is your transport, and accordingly you can calculate. It is there. Ready-made calculation can be done how much carbon dioxide or carbon equivalent you are emitting to the atmosphere. So therefore you can reduce the greenhouse gases. You can maximize the sink. How can you maximize the sink? The sink, who is the sink actually? Ocean is the sink, one example. So therefore you should know whenever you are going for tourism near the ocean, don't spoil their putting of the plastics. Okay. Similarly, very bad practice we have got. In polythene we took something for food. After taking the food, we throw the polythene somewhere. But put it in the dust bin so that it will be collected, it will be reprocessed, it will be recycled, it will be reused, etc. Then another sink is the water bodies, other water bodies, river, ponds. Everywhere if you go to village nowadays also you will find there will be a pond. Every household has a pond, small pond. And every village will be a big pond. But nowadays you will find that these ponds are, okay, so we are just destroying. And pond absorbs the carbon dioxide. Why it was kept? You will find end of the village there will be temple and there will be a pond. Because the pond can absorb the carbon dioxide. So that environment will be neat and clean. But that we forgot. We couldn't understand the traditional practice. And now we went and putting up that, okay, I will absorb that, this is my, I will construct a building and it will go on rent, I will get money. You know, money is not everything, right? Environment is also important for you. Okay, so like that, there are many such activities you can do. The solar panels. You can put up solar panels in your house. So you can put the wind turbines, or you can have the use of renewable energy. So for incandescent light, you remove it, you put up the LEDs. Okay, so similarly you can put the plant trees. I told you that. Okay, so turn light. So for example, now when we will go out, somebody will switch off. If he does not switch off, then it will go on for 1 hour, 2 hours. Do you know what is the cost of 1 hour? Okay, 1 kilowatt hour. Okay, 3 unit or 5 unit, whatever it is, cost you know. Now, so if it can be automatically switched off, or if someone, when we go out, we should switch off. So by that way also we can, then that's no to politics, follow 3 R's. 3 R's means reuse, recycle, okay, all of you know by that. Then awareness. Please make your family aware, be aware first, and then make others aware. If that is the case, then we together can help society. Next, please. Now let us take an example. So we know that how can you measure actually impact of human activities? I am taking one example here. Say we have got the carbon. Carbon atomic weight is 12, and atomic weight of oxygen is 16. When I say carbon dioxide, it becomes 44 grams. One molecular weight of carbon dioxide becomes the 44 grams. Now, assume that a coal has 50% of carbon in it. You know, we get coal from mines. So assume that it has got 50% carbon in it. So therefore, 1 kg of coal contains 0.5 kg of carbon. And this 0.5 kg of carbon, if I convert into carbon dioxide, because carbon plus O2 becomes carbon dioxide, so you will find that this burning of 1 kg of coal, which is giving you 0.5 kg of carbon, it is giving 1.83 kg of carbon dioxide. Can you just imagine? Okay, you will be feeling that you just brought 1 kg of coal and you are giving 1.83 kg of carbon dioxide into the atmosphere. That we should understand. I just show you the calculation to impress upon you how much you are harming when you are utilizing coal. You will say, no, sir, I am not utilizing coal. Am I correct? You are not utilizing coal. Or you are utilizing coal? Indirectly you are utilizing coal. So next example, next please. So now let us find out the thermal energy density of the coal. Okay. So thermal energy density, if you just see, it is actually 24 megajoules per kg. Okay. So that means 6.67 kilowatt hour per kg. Fine. So if your electricity generated per kg of coal, how much it will be? So therefore coal-fired power plants are very efficient actually. If it is efficient, then they will generate this one 6.67 kilowatt hour per kg, and they are still limited by the laws of thermodynamics. Actually 40% thermal energy in the coal is converted into electricity. So first is the thermal efficiency, thermal energy efficiency. It is about 24 megajoules, so therefore 6.67 kilowatts per hour. From there, it is 40% actually is being converted into electricity. It's not that 100% conversion. We know energy conversion. One form is converted to another form. But here it is not that 100% is being converted into electricity, only 40%. So by that way, you will get 2.67 kilowatt hour. Okay. Then how much is required to light a 100 watt bulb? If I make a calculation of 100 watt bulb, means it is 0.1 kilowatt light bulb for 8 hours per day for a year. In such case, it will be 0.1 into 8 into 365. So it is 292 kilowatt hour. Okay. So coal required for this purpose, I will divide. 292 divided by 2.67, it becomes 109 kg. So one bulb, 100 watt, if you are putting it on for 8 hours in a day, so for a year, you are burning 109 kg of coal. Now you just imagine. So therefore you can just switch it off in one room. It may be 3-bedroom or 2-bedroom you are staying. In one room you are not utilizing. Switch it off. Then how much you are saving towards that? Okay. So CO2 production, if you just look at, I have given in the previous example, I have shown CO2 production. 1 kg of coal gives 1.83 carbon dioxide, kg of carbon dioxide. Now carbon dioxide will give you around 200 kg. So you are providing 200 kg of carbon dioxide in the atmosphere by just putting on 100 watt bulb. Even you will not put a 100 watt bulb, you put a 250 watt bulb or something like that to put up, because light is not sufficient 100 watt bulb. Okay, next please. So therefore you can, if you can minimize the utilization of the electricity in your house, then certainly you can minimize the greenhouse gases. So now let us consider the carbon dioxide if we utilize the LED. So LED, what happens actually? Say for example, you have got LED, this is a 80% reduction. Okay. So 100 watt bulb, you can have 20 watt. There could be 80% reductions in LED. So by that way, you can minimize. I am not going to entire calculation. You can see that the CO2 emission, how much coal you can save. 438 kg of coal you can save. You are replacing the incandescent light with the LEDs. So by that way, if you replace the solar or wind bulb, there are so many things are there. So I'm just giving one example of replacing with LED bulbs. Next, please. Now, similarly, improving public transport systems, I have already told, you can reduce greenhouse gases like whatever is carbon dioxide, nitrous oxide, solid particulate matters, sulfur dioxides, etc. You are also reducing air pollution. Just like uneven, yeah, that what do we, odd and even we do. Why we do odd and even? Because you can reduce the air pollution also by that way. So if cars are replaced with efficient public transport system, say about 50%, it would lead to one bus replacing 30 cars. You know, in a car, in a bus facility, how much? 52 capacity, standard capacity of bus is 52. Now car, you have got, you will find one person driving, only driver will be driving, nobody will be there also sometimes. Okay. Say bus emits about 700 grams of CO2 per kilometer compared to 98 grams per kilometer by a car. Now you just compare 98 grams per kilometer per car, multiply it 30, then accordingly you can find out that how much you can reduce by utilizing the mass transport like bus or metro or whatever it is. So there are many other additional benefits also. So you can avoid accidents, you can avoid the traffic jam, and also pollution I told you, electricity efficiency I told you, and so many things are there which can be gained if we adopt these practices. And I told you, you can make some law for yourself. Say within 1 kilometer I will never use the car. Okay. Or for example, if I'm going to office, we can, what is that called? A group of people can come together and travel in one car. Huh? You can go for that pooling, carpooling also. Yes, like that there are many such uses. Next, please. Yeah, saving water. This is a very good example I will tell you. When you save means save actually. What you do actually? You will keep your tap on. Just think about that. Is it needed to keep the tap on continuously while saving? So you just switch it off, whatever you do. So by that way, how much water you are spoiling? Like that. So you can utilize this water also in gardening, etc. Where, and also so like that, bathing. Every step, if you go from morning to evening, every step you can minimize. Another way, brush. Which brush you are utilizing? You can use. Just imagine in. I will my बचपन में बात करूं. हम तो सिर्फ बेम्बो का जो स्टिक है ना इसमें, नहीं तो नीम का, बेम्बो का, दूसरा का यूज करें. Now what happens actually when we come to cities and towns, we started purchasing the toothbrush and all are plastic. And these are not, one is, you will throw it and it is thrown. It is not degradable. Plastic is not degradable. And by that it will go on increasing the greenhouse gases. So therefore what we will do actually? We can go to the backstage. We can assume all those wooden brushes. Now the wooden brushes are sold out in market. You can find a wooden process. You can utilize wooden process. So by that way also you can minimize the greenhouse gases. So like this, if you just look at the type of cloth you are utilizing, the iron, do you know how many times you are ironing? Every day office one shirt, new shirt. Okay, new shirt means newly ironed shirt. Next day another shirt. You know, by that way how much carbon dioxide you are contributing to the society? You cannot use one iron shirt for 3 to 4 days or 1 week. No. So you will feel that no, every day I should have newly ironed shirts. So by that way also you are contributing to. So sometimes somewhere you have to compromise for the society, if you are really conscious for the society. So like this, if I can put the shirt in a better form, निकाल के अच्छा से रख दो, फिर दोबारा iron ना करना पड़े. Actually, by that you can utilize second time, third time, fourth time. Many of us also utilize second, 3 times, 4 times also. But I am just putting it on. Okay. I'll tell you, in childhood, we never did ironing of the shirts or the pant. Whatever was there, just wash it and wear it. But now we became conscious, we should look bright, we should look beautiful, we should look smart. Also we teach our children also the same thing. You should be smart by all these things. So so-called smartness also spoiling the society. So we can do something towards these directions. So I just gave some example of everyday life. In food also, do you know, I am a vegetarian, and someone is non-vegetarian. Who is contributing more towards the carbon dioxide? Non-vegetarian. Okay? So non-vegetarian is contributing more to carbon dioxide. Okay? So like that there are many such things. What food you are consuming. So by that way it decides. What cloth you are wearing, that also decides. What shelter, that also decides. So all these things decides about your consumption, about your contribution towards the carbon dioxide or equivalent in the society. Next, please. Yeah, benefits of reducing electricity consumption, everybody knows that. Already I have told that. It can help mitigate climate change and improve air quality, it can improve the sustainability, all these things. Electricity grid point, you know, every time in the summer season in Delhi, there will be power cut at night. Have you thought at any time, why this power cut? Because all ACs will be on at that time, demand increases, therefore our grid fails. Why is it so? Can we not keep our AC at, say, for example, 20 degree or 23 degree? At the time Sushma Swaraj madam called at the time 25. Now again government is coming of that, you have to keep it 20. But we go up to 16, 15, like that, so that it becomes complete. At that time what we do actually, no? We will put a blanket on our body. We put the blanket and make the temperature 15 degrees, 16 degrees Celsius. What a laughing stock we are, actually. Why to put up this blanket? Why to put up this bed sheet? Instead, rise the temperature. Okay? And put in such a way that throughout the night it will not run. Now the monsoon season, keep the fan on, and people do not keep the fan on because this will, no, it will bring the heat from the roof, and by that way it will not cool. So therefore, by that way also you cannot reduce and go on increasing. You know how much AC consumption you know already, electricity consumption. And one way is that it consumes more electricity, which is coal-based. Other way is that it is also pumping energy outside. It is not that your environment is cool. That doesn't mean that outside environment is becoming cool. Outside environment is becoming worse, actually. So the servant or the people, those are staying nearby, they will feel the heat of you. Okay. So like that, there are many such ways and means by which we can minimize our contribution as an individual. There are two policies in the society. One is the macro policy. Macro policy tells like this: you. I am not responsible for this. Everything is you. Government is responsible for these things. What is happening is because of government here. Government should bring out the rules. Government should say that nobody should utilize the AC under temperature of 25 degrees Celsius. Government should stop transport. Government should provide mass transport. All this towards government. Nobody raises finger towards himself or herself. What you can do? So what I am talking here actually, the micro level policy at the individual level. Macro level policy is taken care. That is slow changing policy. It will be there. Because government is who actually? We are all government. Okay. So therefore, instead of blaming government, every individual also should do something. In the government also, this institute is a part of government. Everywhere you are the government. So you can do for the institutes also. Say for example, the toilets. Let us make in such a way that if I come out of the toilet will be dark. There will be no light. Otherwise, toilet light will be on dawn to dusk. As long as the चाबी वाला नहीं आएगा तो तब तक वो light on रहेगा, है ना? So there are many such similarly street lights. So there are many things you can just do something for the institutes as organization. Similarly in your society, you have got RWA. There also you can do something, awareness campaign, all these things. You can convince the people to do something. By that way, you can reduce the contribution towards the greenhouse gases. And hence you can ensure a sustainable environment, not for you, but for your future generation, your grandson, your granddaughter, because the life period of carbon dioxide is about 100 years. If you stop now also, it will have the adverse impact for next 100 years. Already you have damaged your third generation. So therefore now, the step, immediate step, if you do now, you can guarantee for your third generation. That is certainly I will give you the better environment. Okay. So with this, I thank you. I think last slide. Thank you. Yeah. Thank you very much.
So if time allows, I think we can take one or two questions.
One or two questions.
Sir, we have seen so many cloudburst events in the past few years. So is this a new reality of our monsoon season because of the climate change? And how IMD is utilizing its models and resources to predict such events in advance? Thank you, sir.
Cloudburst is a weather phenomena which occurs in a very limited area. Maybe one village or two villages or a part of the city. And its time period is also quite less. It's short-lived. So therefore, it is very difficult to detect the cloudburst. Next is that it develops usually in the hilly areas. Say Jammu Kashmir, Himachal, Uttarakhand, Arunachal Pradesh, or sometimes in the Western Ghat region, Kerala, Karnataka, Konkan, where typically you do not have many observations. It is very difficult to put up observations there because you do not have roads, you do not have electricity, you do not have water, there is no habitations, so it becomes difficult. So you go by the remote sensing observations. Remote sensing comes through satellite and the radar. Satellite, what we have at present, it does not have the capability to detect the cloudburst because resolution is 4 kilometers. And cloudburst can occur within 4 kilometers. So satellite has limitations. A radar has high resolution, 350 meters. We have put up 40 radars. It is not covering entire country. At present, it covers around 85% of the country. 15% of area is not yet covered, and those 15% are mainly in the hill areas. Even if we want to put up the radar, we cannot put up in the higher reaches of the Himalayas. Okay. So there are some limitations, but still we are improving the radars. And 126 radar, when you come up, there will be redundancy and 100% area will be covered by that. So at that time, perhaps we will be able to detect the cloudburst. The cloudburst is a phenomena when rainfall amount exceeds 10 centimeter per hour. It is very few phenomena it occurs. And the trend, because of the climate change, we have studied that, we found that there is no increase in frequency of climate change, in frequency of cloudburst over our region. There is no increase. But there are some studies when rainfall reaches 5 centimeter, that is micro cloudburst people say, that frequency is increasing. Even 5 centimeter rainfall also can cause landslides. So therefore, it is a threat, and usually it occurs in hilly regions that has to be addressed. And we are addressing towards that. As I told you, we are increasing our modeling capacity and observational capacity.
One more question, please.
Good evening, sir. Sir, in the presentation, like you mentioned about how AI can be useful in the IMD department for predictive analysis. So I wanted to ask for some example, like how in the future AI can be helpful for a certain particular situation. Thank you.
Artificial intelligence is just a data science. If you've got more data, then you can generate knowledge from the past data. That is called deep learning. And also you can have the predictability. You can also predict AI. So there are various tools and technologies that come up. Then how? If it needs data, you should have data. I am happy to inform you that we have got 100 years, more than 100 years, from 1901 onwards, rainfall data are available in digital format. Satellite data are available from 1983 onwards. Radar data are available from 2002 onwards. Automated station, as and when, all the data are digitized by IMD. So these digitized data can be utilized in artificial intelligence and machine learning to develop the new models. At the same time also we have come with the numerical weather prediction models. There are 7 models running every day. Huge data are generated. Those data also can be utilized. So what I say in future that it is not simply AI model, but physical model what we have plus AI model will work together just like dual engine concept or digital twins. And these two will address the requirement. Then what is the requirement? Requirement is that at present our model is providing forecast at block level. We do not have forecast at the, we started a Panchayat level forecast, we started only one model, we have come up like that. But one model will not help because models differ just like doctors differ from each other. If you take a cold fever also even, you go to 5 doctors, you will get 5 different prescriptions. Okay, so like that here also the models give different forecast. So what we do actually, we go for a consensus forecast. And it has been, theoretically, it is shown that AI/ML model, if used in physical modeling system, can improve the forecast accuracy. At least it has seen that cyclone track forecast can increase, not intensity forecast. Intensity forecast is not increasing. So there are many such parameters which can improve, which cannot improve also. But there is a scope, we can go for AI/ML towards improving the forecast accuracy for the severe weather and general weather. Number 2 is that we can improve the downscaling. Downscaling in the sense that from block level, I can prepare the forecast. I give the data for forecast for block level. From that, AI/ML can be applied to find the forecast at Panchayat or the village. When I will have the forecast at Panchayat, we can go to village or the sub-village or the plots. Now, second is that sectoral applications. For example, malaria. We have got the forecast of temperature, rainfall, humidity, and these are the vector. Malaria is a vector-borne disease. It depends upon all these parameters. But to link it, there is AI/ML. If I give the data about the occurrence of malaria, I got the data about temperature, pressure, wind speed, rainfall, humidity, etc., I can utilize this data to develop a model to predict malaria, occurrence of malaria. So like that, there are many health concerns which can be utilized. Nowadays, we have developed a cumulative heat factor, for example, we are calculating based on AI/ML at present. Cyclogenesis, we are calculating based on AI/ML at present. There are many AI/ML utilized at present also in small environment. There are also AI/ML model globally available which are utilizing at present to provide the forecast, but we do not use only AI/ML. That day has not come. We utilize combination of all models whatever we have. Now similarly, you can utilize the AI/ML to improve the data entered into the numerical representation models and the post-processed products. For example, agriculture I told you, health I told you, power sector, there is a renewable energy. people are going for establishing the wind turbines. They want forecast in the wind turbine, place of wind turbine. How to give that forecast? So I can give the forecast for that particular area, but they want very specific forecast for that. So there could be intervention to downscale the information as per requirement of the user. So these are the few examples I told you. So there is enough scope if any of you want to carry out any research, the data are available freely. We are providing data free of cost. And also we have got another strength, that is the knowledge. It is a very old organization, 1875, so people are there, you can collaborate, you can have joint work.
Thank you, sir, for elaborating different aspects of climate change and its impact on Earth, and most importantly on all of us, with the mitigation and adaptation practices. Now I would request DDG sir to present a memento to our distinguished faculty. Thank you, sir. Now I invite Shri Ravinder Singh, IPTAF OT batch 2024, to extend a vote of thanks.
Good evening, sir. Sir, it is my privilege to extend vote of thanks on behalf of NCA-F. Sir, this session was quite enlightening and thought-provoking. You told us about the science of climate change, the climate change and impact on extreme weathers, its impact on food security. We were especially enlightened to know the improving role of IMD, especially in terms of multi-hazard early warning system in managing disaster. And also, sir, we are especially grateful for your emphasis upon the roles and responsibilities of each individual in checking the climate change. It was very important lesson for all of us. Thank you once again, sir, with deep appreciations. Thank you, sir.